Welcome back to the final installment on inequality by addition. So let's get started. Here we have an absolute value of x plus 7, which is less than or equal to 3x plus 13. So what have we done traditionally when we have inequality is, first you treat the x plus 7 with no changes. So we'll take x plus 7, which is less than or equal to 3x plus 13. We could add x on both negative x on both sides, which would lead to 2x plus 13. And then we could add negative 7 on both sides, right? Which would give us 0 less than or equal to 2x plus 6, right? We could add negative 6 on both sides. I guess, yeah, that will work. So that'll be 2x. And then you can divide by 2 on both sides, which would give negative 3 less than or equal to 2. Sorry, less than or equal to x, right? So we know x is greater than or equal to negative 3, right? That's one of the answer choices. So we have to do this is the positive domain. So let's do the negative domain. To do that, you just simply add a negative in front of the x plus 1 and keep them within brackets, and that's less than 3x plus 13. If you divide or multiply by negative on both sides, then you end up with x plus 7. When you do that, be careful to do two things. One, you have to flip the sign of the inequality, and you also have to add a negative sign on the other side. Make sure these two terms are in the brackets, otherwise you're going to cause a lot more confusion that's probably could be easily avoided. So now let's go ahead and solve it. So we can multiply the negative into the terms, which would give us this. Now to this, we can start simplifying this expression right here. We could add plus 3x on both sides, which would give us 4x plus 7 greater than or equal to negative 13. We could add plus 13 on both sides, which would further simplify this side to what, 20 and 0. Now we could add negative 20 on both sides, which means 4x is greater than or equal to negative 20, right? And if you divide by 4 on both sides, that'll be x greater than or equal to negative 5. So x can be greater than or equal to negative 3. X can be greater than or equal to negative 5. Okay. Let's go through the choices. X can be greater than or equal to negative 3, right? This is possible. And this is, on a fly, when you're trying to do these problems, you might get carried away because of the directionality of the symbol. But this is incorrect. This is opposite. Here, x is actually less than or equal to negative 3. X is less than or equal to negative 5. So this is incorrect. X is greater than or equal to negative 5, which is fine, but x cannot be less than or equal to negative 3, right? Because x is greater than or equal to negative 3. So this won't work. This obviously won't work for the signs. X is greater than or equal to negative 5. So technically, there are two correct answers for this problem. I guess if this type of question were to appear, then they would have to give it something like 1 and 2, 2 and 3, 3 and 4, or it might be part of part of a section where they might just ask you, they might not have both. Will be likely option here. But considering this was a real test question, I would probably say that if my memory was right, it was something like 1 and 2, 2 and 3, 3 and 4, something like that, right? So in that case, it will be 1 and 5, okay? So because they're both correct answers, all right? All right, if you have x plus 1 less than 4, y minus 2 less than negative 1, then which of the following could be value of x plus y? What you have to do is to further simplify x and y to the lowest level as possible, okay? So if you could add negative 1 on both sides, then x is less than 3, okay? Right? Similarly, y minus 2 is less than negative 1. If you add plus 2 on both sides, y is less than 1. Considering all our answer choices are integers, that means x can only be 2, 1, 0, negative 1, negative 2. Y can be 0, negative 1, negative 2, and so on. You might ask, well, could that be a 2.99? Could it be a 1.99? No, the answer choices are all integers, so you want to keep your options integers as well. So if x is less than 3, if 2 is the maximum you could have, and 0 is the maximum you could have, the most you could even have for x plus y, okay, would be a 2. So right away, all these numbers are impossible. Okay, you can't have these numbers, right? However, x is less than 3, 0 could be a value. Y less than 1, 0 could be a value. 0 plus 0 is 0. Or x could be plus 1 and y could be negative 1, which also gives you 0. So it didn't ask you how many times 0 is appearing or how many combinations would result in 0. It's just asking which of the following could be. So it's just asking for under what circumstances can you have any of these values, and which means 0 is likely a possibility, and we've shown that we can have 0, so that is the correct answer. Okay, what values of x make the following statement true? So we have an absolute value of x minus 3 is less than 9. So just like you've always done, first take the value x minus 3 as it is, and then is less than 9. So if you add plus 3 on both sides, we know x is less than 12, right? Similarly, that's for the positive domain. For the negative domain, we just simply add a negative in front of it and keep the x minus 3 within brackets and less than 9. We can multiply or divide negative on both sides, in which case the sign of the inequality changes, and we also have to add negative to the 9. And now we can add plus 3 on both sides, which makes x greater than negative 6. That means x is greater than negative 6 and it's less than 12. Is there a choice that depicts this exact expression? I think there is a choice, so it's D, right? Solve for x. So again, we have to solve for the positive and the negative domain separately. Let's do the positive domain first, which means we have x plus 5 less than 2x plus 16. We could add negative x on both sides, which would leave us with x5 is less than x plus 16. Similarly, we could add negative 5 on both sides, which would leave us with x plus 11. We could add negative 11 on both sides, which would make this side 11 go away, which means x is greater than negative 11. That's the positive domain. Let's do the negative domain. So we have negative of x plus 5, which is less than 2x plus 16. We could multiply or divide negative on both sides, in which case the sign of the inequality changes, but also don't forget to add a negative to the right side and put the terms within a bracket. So now let's go ahead and multiply through the negative into the terms. So it'll be negative 2x and negative 16. We could add plus 2x on both sides, which would result in 3x plus 5 greater than negative 16. We could add plus 16 on both sides, which would result in 3x plus 21 greater than 0. We could add negative 21 on both sides, which would make this, and then x is greater than negative 7. So x is greater than negative 11, x is also greater than negative 7. Is there a choice that depicts that? This is incorrect, because while in one case x is greater than negative 7, it's also less than greater than negative 11, it's less than negative 7. That's not what we predicted here. X is greater than negative 11. This is likely an answer choice. This is correct, but this is incorrect. So we have a contradicting here. So overall, this choice is incorrect. This is incorrect. I accidentally hide the fourth choice while I was trying to construct the slides, but it doesn't matter. That was, I think it was none of the above. So that's actually not the correct answer either. I think it was none of the above was the fourth choice. That's also is incorrect because we know x is greater than -11. So that is the answer. And this is the last problem in the series of videos on inequality by addition. So let's get going. So we have 4x plus 5, which is less than 49. So if we subtract -5 on both sides, we end up with, what is it, 44, and x is less than 11. And this is the answer. Right? So if you enjoyed this content on, or you learned something on this content on inequality by addition, please consider subscribing to my channel. Your support will greatly help me add more and more content to my channel on SAT and ACT math problems. And please stay tuned to my channel. I'll see you with another video. All right, bye-bye.